Okay, hello everybody. So today we're going to continue our discussion with Chapter 6, Section 1. And in the last video, you saw how we can determine how many solutions a system has. Now we're going to continue doing that with four problems here today, but I'm going to show you a little bit more information so what we're getting hopefully makes sense to you. So let's get started. So the first example is going to be the same. Actually, all four examples are going to be the same as what we did in the last video, which it wants us to determine the number of solutions each system has. But I'm going to do a little bit extra with these, and I'm actually going to graph both of these equations so you can see the visualization of what we're verifying. So as I look at this first one, I'm going to get my m and my b for each one of these. This first one, m is -1 and b is -3. In the second one, m is 1 and b is -1. So again, y equals mx plus b. You can see how the numbers line up. M is -1, b is -3. So I'm going to go ahead and graph these just to show you. Before I do that, I do want to write what this would be. So if you look at the m's are different and the b's are different. So if we go back up to our table, if the m's are different and the b's are different, then that means we're going to have one solution. So there's one solution. Now I'm going to show you what that solution is going to look like right now by graphing this. So I'm going to draw a coordinate plane very quickly. We'll get these set so they're there. And I'm going to go probably 3 on each direction for now. And let's graph both of these. So the first one I'm going to graph in red. The slope is, well, first of all, we got to start with the b, which is -3. And then we would go down 1 over 1, which would put us about there and there. So if I drew my line, I'd have approximately a line that looks something like this. Now I'm going to draw my second line. I'm going to make it purple for this line right here. And this one, you would go down to -1, and then your slope is up 1 over 1. And then you would go up 1 over 1 again, like this. And you'd have a line that looks something like that. Close enough. And what you can see is they do indeed intersect in one place. They intersect right there. And that means there would be one solution. Now, the solution is an ordered pair where they intersect. Now, I'm not going to have you write that down right now. We're just determining how many solutions there are. We will be doing that later. Okay, let's look at this next one. Same as what we did the other day. This one is easy because it's already in slope-intercept form. So the slope is -1 and the b is -3. Now this one, though, we need to get in slope-intercept form. So I'm going to subtract 2x from both sides. And do my work for this one over here. I'm going to get 2y is equal to -2x minus 6. Then I'm going to divide by 2 on both sides. And I'm going to get y equals -x minus 3. And so this one, m is -1 and b is -3. And if you look, the m's are the same and the b's are the same. So whenever I go to graph this, these are going to work out to be the exact same line, as you'll see here in just a second. Like that. So the y-intercept is -3, and then the slope would be down 1 over 1. And I could go ahead and draw my line. It would look something like that. And if I drew the other line, it's going to be the exact same thing. It's going to intersect right on top of that other one, and it'll look like this because it has the exact same m and b. Start at -3 and then go down 1 over 1. So what that means, though, is because m and b are the same, if we go up here, again to our table, if m is the same and b is the same, there's an infinite number of solutions. So scrolling down to our problem here, m was the same, b is the same. They end up being the same line. So every point on the line intersects with every other point, and there's an infinite number of solutions. So you can say, you You can do a sideways 8. That's the symbol for infinity. You can say infinite number of solutions. Okay, 2 more. This is number 3. Same idea here. The first one is in slope-intercept form, so m is going to be -1 and b is going to be -3. Now this one we do need to get into slope-intercept form. So I'm going to have 2y is equal to -2x plus 4. And I'm going to divide everything by 2. I'm going to get y equals -1x plus 2. So in this one, m is -1 and b is 2. So if I look at my m's, the m's are the same, but the b's are different. So if I go up to my table again, m is the same, b is different. There will not be any solutions because the lines are going to be parallel. So we'll write no solution. Now let's graph it and see if that's what we end up with whenever we plot these 2 equations. So let's see here. I need to do that, and let's graph the first line in red. So the first line was the m was -1 and the b was -3. So we're going to go down 3. Then I'm going to go down 1 over 1. Then I'm going to go down 1 over 1 again. So I'm going to get a line that looks something like that. Now this second one, let's do it in purple here. The second one, the b was 2. And then the slope was down 1 over 1 again, like that. And when I draw that line, that's a little bit off. Let me see if I can be a little bit more accurate with that line. Second one, when I draw that line, you can see that both of the lines are parallel. They're not going to intersect. And that's exactly what we said based on the information that we got from looking at the m and the b. The last one, both of these are in standard form. So both of these equations are going to need to be put into slope-intercept form before we can compare their slope and their y-intercept. So when I subtract 2x from both sides, I get 2y equals -2x minus 6. Then I divide all this by 2, and I get y equals -1x minus 3. So the m in here is -1, and the b is -3. So there's my m and my b. Now for this second one, this one's a little bit easier. I just subtract 3x from both sides. And I get y equals -3x plus 3. Here m is -3 and b is 3. Now comparing those, if I look at the m's are different. The b's are different. So m's are different, b's are different. Going back to the table, m is different, b is different, there's going to be one solution. So that means the lines will intersect in one place. Now when I graph these, we should be able to see that. Go ahead and draw a coordinate plane. And the b is 3, and then we're going to go down 3 over 1, and we'll draw our line right there. So there's our first line. That's this one right here with the stars, all the stars with 4 stars. Now I'm going to go over to this second one. I'm going to use dark blue for that one. I'm going to go down to -3. Then I'm going to go down 1 over 1 like this. And when I draw this line, you can see they're going to intersect right there. There is indeed one point of intersection, which is what we said before. So we would write one solution. So that's what I got for you guys today. If you have any questions, feel free to email me. Have a great day.